Tech.
Good morning, everyone. My name is Asya Tomsky. I'm with Coverity. And today we're going to talk about analyzing builds and improving your overall software quality and integrity by improving your build process. Now, what is a build? Well, first of all, the build process, as I'm sure you all know, is the process which turns the software that your developers write into some sort of a package or a standalone artifact that your customer, the end user, will get as a delivery, and they will then execute on the deployed system. So they don't need to know how to compile your code. They don't need to know anything except, some way to run it. And what that means is that most of us hopefully have an automated system between the development of software and the delivery to the customer. What are some of the things that can be wrong with that step? Now, obviously, we all know how software can malfunction, right? You can have crashes or memory leaks. However, if your builds are malfunctioning, you could have symptoms such as build being slow. Now, that doesn't really affect your end customer, except when it slows down the development process and your software simply is not good. So builds are slow or brittle. Brittle means sometimes they fail, and at other times they may produce incorrect output, so they have to be repeated and modified. They can be difficult to modify when you start to expand your system. And the fact is that in a lot of places, what happens during the build is a mystery. So I'm sure we've all been places where we needed to add something to the system, and it took, finding that one person who really understood how the build was structured in order to be able to do so successfully. We did some surveys, and I'm sure you guys are here because you're in in the similar situation where you're wondering if your build can somehow be made better. The survey of our customers, so these are customers that were using our flagship product, Prevent, which is static analysis for their developers. 2/3 of them plan to improve their build system in the next year or two, and that includes completely rewriting it or trying to make it more efficient, more repeatable, more effective in various ways. There's several types of build failures. The loud failures are ones we've all encountered if we've ever been a software developer, and that is you kick off the build and something doesn't compile, or a test doesn't pass, or the build crashes for some other reason. Those can be easy to recognize because at the end, things are not delivered. However, they may or may not actually be easy to fix, and there can be delays built into the development process because of that. Silent failures are much more dangerous. That's when the build completes successfully. However, the results are incorrect. And incorrect means something other than what you intended. For example, a wrong library is linked in, or an older version is linked in with a newer version, or a slightly incorrect compiler variant was used. Maybe somebody upgraded the compiler, resulting in slightly different information, slightly different package being delivered. Intentional failures are probably less common, but when they do happen, you hear about them in popular press who don't really understand software but love to trumpet security vulnerability, somebody broke in because of something, and sometimes it could be that, an insecure version of some library is linked in and open source is used without verifying that it's a latest version with bug fixes for various problems included. There's certainly a lot of different ways that build can slow down your software delivery. One of my favorites is, when you contractually are required to deliver, a fixed version of a particular build to a very important customer, and when you go back to do so, you integrate the fix in and you try to build, and maybe the build fails. Or the build succeeds, but you didn't realize that since the previous delivery, something changed in the system, and there's no way to verify and to assure the customer that what you're delivering is exactly what they had before plus this one single change. So inadvertently, you may be delivering something other than what you must. It can be difficult to analyze, you know, if you have inherited a large complex system, you're trying to optimize things, make things faster. It can be very hard to figure out what exactly is causing problems, et cetera, et cetera. Hardware utilization, obviously, you can have lots of hardware. If you can't figure out how to parallelize your build, for example, it can be very frustrating that, you know, most of your machines are sitting around idle while one is cranking along. Core capabilities of build analysis. So first of all, you know, I want to emphasize this is not a build acceleration tool. This is not like some of our partners or other companies out there, you know, where you have to re-implement your build within their framework or in their system and then it'll run faster. Instead, this is analysis that's analogous to Prevent for C and C++ or Java, where we point out issues in your build and then you take action to correct them. So we may pinpoint some causes of slow build. For example, there are duplicate processes that are invoked many times exactly the same way. Well, you know, if you could figure out that you don't need that, you can consolidate that into reducing the number of things that run during the build. Also, just to show you which processes consume the most time, right? You gain some visibility into how long each process takes, the duration, how many times it's invoked, how many files is it reading and writing. Is it reading and writing files that it shouldn't be? Now, this does not require any changes to your build environment, and I'll show you kind of how that works. One of the other things it can give you is a bill of materials. So for your build, at the end of it, you can produce exact list of all the files that went into the production of whatever came out. The nice thing about that is that it gives you a way to record it so that you can be in compliance with, you know, whatever agreements you have with your customers, and you'll have the ability to verify in the future that you're delivering exactly the same thing. You can also then make sure that, you know, everything that goes into the build that is source is in fact in your source control system, and everything that goes in that's not source that you have a way of reproducing on a different machine, for example. So leaked files, actually, that's another good one. If you create a build and then you have to modify a few things, you know, how many people have typed make clean and kind of assumed that the right thing will happen so that you can then rerun the build and get the same output. The problem is that if people are modifying your make files and somebody forgets to update the clean target, there may be files that are left hanging around after you run make clean. And then what happens is an old file may end up getting included with a newer build. So basically, we focus on build integrity and correctness, not specifically build acceleration, although we do give you information that can help with that. So this is kind of a list of stuff, right? You want to make sure that the delivery of your software meets your standards. You don't want to include improper components. You know, productivity lost, a lot of times people think of productivity lost as like the time the developers are sitting around and waiting for the build to complete before they can do their check-in. And certainly that's part of it. But to me, it can be even much more damaging if, you know, let's say, you know, the primary build machine crashes and, you know, your IT guys jump up and spin up a new machine and you put the build on it and you kick it off and it fails. And it's the exact same process that ran on the old machine, and there's absolutely no information that you can find that tells you, oh, it's because, you know, a particular patch is not, you know, installed on this one, and therefore you have slightly different versions of various executables, or, you know, some other information like that, where what that causes is your entire development department could be sitting around for a day waiting while somebody tries to figure out what exactly is different, you know, on the new machine from the old machine. So understanding, you know, what your build depends on, and if you change one thing, what's likely to break.